Welcome to Maths and Science by IITian channel. In this lecture, I will be discussing about a very good Maths Olympiad level or International Mathematics Olympiad level examination question which involves factorials and also exponentials. The equation given is a to the power of b into b to the power of a is equal to factorial c to the power of ab. Here ABC values are not given, only one condition is given, that ABC are positive integers greater than 1. We have to find the possible solutions and we have to show that these possible solutions are only possible and not any other solution is existing. It's not about finding the values of ABC, but this problem requires to show the uniqueness of the solutions. If there are three solutions are there, the three values of ABC, the same should be proved that except these three, others are not there. That's what we are going to do it. And in the previous lecture, which is on live at present, in which I have used Bertrand's postulate and also prime factorization theorems and advanced theorems of number theory, and proved that there is only a possible solution of 2 and 3 and 4. Only one unique solution. That is a to the power of b into b is equal to factorial c. Here a to the power of b into b to the power of a is equal to factorial c to the power of ab. Let's find out what may be the possible solutions and whether they are unique, whether they are beyond the possible solutions. Are there any other possible solutions? For whatever we assumed, we have to prove. Now, please see my previous lecture which is live now. Please see that, so that you will get a glimpse of Bertrand's postulate and prime factorization theorem. For details, please see the previous live lecture which is live now. Let's go further to solve this. Question is A, B, C are greater than 1 and positive integers given. Find solutions for a to the power of b into b to the power of a is equal to factorial c into factorial c to the power of ab. On the face value, it looks that there are infinite solutions, but that is not the case, and at the same time it looks like it's an impossibility. That's also not correct. We will have a solution, we will have limited solutions, and we will try to find out whether it is a single solution or 2 solutions, 3 solutions, 4 solutions for the given conditions. What is given here? A, B, C are such that positive integers greater than 1. They are not equal to unity. And the given equation is a to the power of b into b to the power of a is equal to factorial c to the power of ab. Here we will utilize the exponents equation. What is the exponent of A? It is B. What is the exponent of B? It is A. What is the exponent of factorial C? It is AB. And to write the exponents equations, to formulate, I have explained in the previous lecture, which is live now. And let the exponents of all the primes of A is B, and let it be denoted by VP, all possible primes. Let it be VP of A. Let this be VP, exponentials of primes of B. And this is exponentials of primes of factorial C. From this, we get the equation B into VPA plus A into VPB is equal to AB into VP factorial C. This is, to get this equation, I have already shown in my previous lecture, which is live now. Please see that. It is a most important step. We got this. Once we got this step, that B into VP of A plus A into VP of B is equal to AB into VP of C factorial. Then that implies, when you divide the left hand side by AB, VP of A divided by A plus VP of B divided by A is equal to VP of C factorial. From the Bertrand's postulate, there will be a prime between C by 2 and C. There will be a prime between C by 2 and C, and the exponent of that prime will be 1. That implies VP of A by, here it is B, here it is B, plus VP of B by A is equal to VP C factorial, implies VP of A by B plus VP of B by A is equal to 1. This is another important observation we have got from the problem given. We have got two observations. One is B into VPA plus A into VPB is equal to AB into VP of factorial C. From that we have derived that, using the Bertrand's postulate, Vp of A by B plus Vp of B by A is equal to 1. Now, the prime in factorial C divides both A and B. The prime which is assumed from the Bertrand's theorem, Bertrand's postulate, will divide both A and B. Implies P divides both A and B. If you want further knowledge on this, please see my lecture on live, which is live now. I have clearly explained everything there. Now we have to find out what will be the possible value of C. Now we have to find out possible value of C such that we can get values of A and B. And here in the problem it is already given A, B, C are positive integers greater than 1. Case 1, C is greater than 1. Hence it is not accepted. Second case, let us say, because all are positive integers, C is equal to 2. If C is equal to 2, what happens? We have to check for C is equal to 2 and C is greater than or equal to 3. What are the possible integer values? C is greater than 1, that implies C is equal to 2 and C is greater than or equal to 3. C is greater than 1, hence C is equal to 1 is ruled out. And C is greater than or equal to 3 is ruled out, then C value must be 2. Before taking the C value to be 2, let us try to see that C cannot be greater than or equal to 3. This is the most important step. How to prove that? If you see the equation, a to the power of b into b to the power of a is equal to factorial c to the power of ab. This implies if c is greater than or equal to 3, that implies, let us say c is equal to 3, that implies a to the power of b into b to the power of a is equal to factorial 3 to the power of ab. That implies a to the power of 1 by a into b to the power of 1 by b is equal to factorial 3 if c is equal to 3, that is equal to 6. That implies a to the power of 1 by a into b to the power of 1 by b is equal to 6. We have to analyze this if c is equal to 3. How do you analyze? If c is equal to 3, that implies factorial c is equal to 3 into 2 into 1. Between c by 2 and c, the prime is p. This divides both a and b. 3 divides both a and b as per above discussion. And its power is 1. This particular prime, if you consider P, its power is 1. And the power of this particular prime on left hand side for A and B, the power of the same prime for A and B is also 1. That implies A should have 3 as a prime factor and B should have 3 as prime factor. That implies A to the power of 1 by A and B to the power of 1 by B is equal to 6. That means power of what we have written here, power of prime in A by A, power of prime in A by B plus power of prime in B by A is equal to 1, which is the equation we have got. Implies power of that prime in A is 1. 1 by B plus 1 by A is equal to 1. That is equal to A plus B is equal to AB. There cannot be any integer greater than 0 as A is greater than 1 and B is greater than 1. This will be possible only when A is equal to B is equal to 2. When A is equal to 2, when A is equal to 2, it cannot have a factor 3. When B is equal to 2, it cannot have a factor as 3. Hence, C is greater than or equal to 3 is not a possibility. C is equal to 3 is not possible. Let us say if C is equal to 5 is possible. Let us check. That is also not possible. A to the power of 1 by A into B to the power of 1 by B is equal to factorial 5, that is equal to 120. This is 5 into 4 into 3 into 2 into 1. The prime is either this is the prime, this is the prime, as per Bertrand's postulate between C by 2 and C. Then this implies from the principle 1 by B plus 1 by A is equal to 1, which we have derived already. It implies A is equal to 2 and B is equal to 2, which implies A and B cannot have factors greater than 2. Hence, C greater than or equal to 3 is not possible. Case 1, we have seen C is greater than 1 and hence C is not equal to 1. 2, we have seen C is not equal to or greater than 3. Now third case, C is equal to 2. That means C cannot be equal to 1. C cannot be equal to 3 or greater than 3. Then let's go for C is equal to 2. C is equal to 2 implies A to the power of B into B to the power of A is equal to factorial C to the power of AB, that is equal to 2 into 1 to the power of AB, that is equal to 2 to the power of AB. A is greater than 1, B is greater than 1 and C is equal to 2. We have to find the solutions for this equation. A to the power of B into C to the B to the power of A is equal to 2 to the power of AB. This is the final equation. For this, what are the possible solutions? What are the possible solutions when C is equal to We'll write it in the logarithms. B into ln A plus A into ln B is equal to AB into ln 2. If I take the base as 2, what happens? B into ln to the base 2A plus A into ln to the base 2B is equal to AB into ln to 2 to the base 2. That is equal to 1. Ln A to the base A is equal to 1. That is equal to AB. That implies, from this we can say, divide the left hand side by AB, we will get ln A to the base 2 divided by A plus ln B to the base 2 divided by B is equal to 1. This particular equation, these two equations, are in the form function x is equal to ln x to the base 2 divided by x. And if you see my previous videos, you can find that even the equation on derivatives f dash x, which I have done using calculus, without calculus and with calculus also I have shown, the maximum value of ln x by x will be at x is equal to e. That I have already on many videos I have shown. The range of this function will be, the maximum value will be at x is equal to e. Please refer to my previous lectures. Maximum value of function x is equal to not is equal to will be at x is equal to e. At the same time, let us say This will be equal to function A. This will be equal to function B. What is the condition? Function A plus function B is equal to 1. When we have put C is equal to 2, this is the equation what we have got, and we have to find out the values of A and B, integer values, so that this particular condition is fulfilled. Positive integer. A is greater than 1 and B is greater than 1, and ln A to the ln A to the base 2 by A plus ln B to the base 2 by B is equal to 1. We have to find out the values of A and B. Do it as a homework. I have already given how it can be represented. That is function A plus function B is equal to 1. For example, A is greater than 1. Let us say A is equal to 2. Then ln 2 to the base 2 divided by 2 and B is equal to 2. Let us say ln 2 to the base 2 divided by 2, that is equal to 1 by 2 plus 1 by 2 is equal to 1, which satisfies this equation. Hence, A is equal to, B is equal to, C is equal to 2 is a solution for it. Now, let us find out. C is equal to 2 and A is equal to 4 and B is equal to 4. Because to the base 2 we have to find out. Because A and B are integers and the sum should be equal to 1. Then ln 4 to the base 2 divided by 4 plus ln 4 to the base 2 divided by 4, that is equal to 2 by 4 plus 2 by 4, that is equal to 1. Accepted. The second solution is A is equal to 4 and B is equal to 4 and C is equal to 2. C is equal to 2 is compulsory everywhere. Next, can we have A is equal to 2 and B is equal to 3? That implies ln 2 to the base 2 divided by 2 plus ln 3 to the base 2 divided by 3, that is equal to 1 by 2 plus ln 3 to the base 2. ln 3 to the base 2 divided by 3. This is approximately 0.52. That is 1.02 greater than 1 and is not equal to 1. Hence, any other combination is not going to give you and satisfy this particular equation. Hence, we can say the values can be interchanging. C will always be 2. And A is equal to 2, B is equal to 4, or C is equal to 2, A is equal to 4 and B is equal to 4, or C is equal to 2 and A is equal to 4 and B is equal to 2. From the symmetry. Or we can have A is equal to 2, B is equal to 2 and C is equal to 2. This is also not a These are the 4 possible solutions for the given problem. Can we check for curiosity? C is equal to 2, A is equal to 2 and B is equal to 8. What happens? What should be the condition for C is equal to 2? What is that? ln A to the base 2 by A plus ln. This has come from the problem itself. We have not invented anything. Should be equal to 1. Now, A is equal to 2. That means ln 2 to the base 2 divided by 2 plus ln 8 to the base 2 divided by 8. What its value? This is 1 by 2. 8 is nothing but 2 cube. 3 into ln 2 to the base 2 divided by 8. That is equal to 1 by 2 plus 3 by 8. This is not equal to 1. There is a fraction. Hence, the possible solutions are 2, 2, 2, 442, 242 and 422. Here, please try to understand how we have got the value of 2. C is equal to 2 always, because C is greater than 1 and less than or equal to 3. There is only possible value for C is 2, and A and B can vary. In C factorial, the prime is 2. That prime divides A and B. Please try to understand this sentence. That prime divides A and B. Here prime is 2. That prime divides A and B. If A and B, 2 divides A and B when A and B are even numbers only. And at the same time, this particular condition to be fulfilled in addition to A and B being even numbers. These can be fulfilled, this particular equation and the condition of A and B to be even numbers can be fulfilled only with this combination. Hence, these are all the 4 possibilities in this particular problem. With this, I want to conclude this lecture. For better understanding of the Bertrand's postulate and prime factorization, please have a look at my other lecture in which I have found the solutions for A to the power of B into B is equal to factorial C. This is what I have solved and found the unique solution for it. And please see that for understanding better the Bertrand's postulate and factorization theorem. By applying Bertrand postulate and also factorization theorem, for the given problem, we have got the solution as 222, 442 and 242 and 422 as the possible solutions. With this, I want to conclude this lecture, and if you feel there is a value addition to you because of this lecture, kindly share and subscribe to my channel Maths and Science by IITian. With a lot of research, I have been bringing up different problems in front of you. If you find any other solutions, please be proactive and find those solutions which are useful for you and easy to understand for you. I hereby explained one of the possible methods how to get the solutions. Please be proactive in finding the other methods also. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture.